In this video, we are going to learn how to create a chatbot. So when it comes to a chatbot is a program where you give a particular text and a response is given to you by that program in return. And in order to create a chatbot, we'll have to import a few libraries. So as you can see over here, we have imported a few libraries, and the first import over here is NLTK. We have imported NLTK, and NLTK stands for Natural Language Toolkit. It is nothing but a platform that is used for building Python programs which work with human language data or the natural language processing. And then the second import over here is string. So when it comes to string, string is basically concatenation of ASCII lowercase and ASCII uppercase string constants. And then our third import over here is pandas. So pandas is a Python library where we can create data frames, and not only creating data frames, pandas will also help us to manipulate these data frames. And we use pandas to read the data set as well. So it will help us to read the data set, load the data set, and manipulate the data set. And after that, we have imported NLP utils. And then the last import over here is matplotlib. So when it comes to matplotlib is a Python library which will help us to create plots. So basically matplotlib is a plotting library, and that's these are all the imports that we have imported. And then what we have done is we have read the data. So there are two ways in order to read a text file. And as you can see, this is the first way where we open the text file and then read the text file. So over here, what you can see is that we have loaded the text in the F, and then we have printed the F. We have used f.read in order to read our data, and this is how our data looks like. Over here, you can see that we have hi, how are you doing, which is our query, and then the response related to it would be I'm fine, how about yourself? So these are all our queries, and then these on the right side are our response for that particular query. And then the other way of loading data is I've used the pandas function over here. I have read the pd.read underscore csv. Again, over here, dialogues.txt is nothing but our text file where all these queries and responses are given to us in that particular data frame. And then over here, you can see we have used names is equal to query and response. So what this does is that it will give a column heading. All right. And as you can see over here, we have our query column and we have our response column over here. These are the names, and this will help us to add a column name. And then we have used sep is equal to /t. /t over here stands for tab space. All right. And then we have read this data in df, and then we have loaded the df. As you can see over here, this is our data frame. It has query column and response column. So before we work on this data set, there is something that we have to do which is called as data understanding. So data understanding will give us a overall view about how our data looks like, and it will help us to understand this data. And as you can see over here, in order to perform the data understanding part, I've used a few functions like the df.shape. So df.shape is a function which will show us the total number of rows and total number of columns present in our data frame. And as you can see over here, we have used df.shape, and then we have 3725 rows and 2 columns as we saw earlier in the data frame. Then the other function that we have used over here is df.columns. So using this function, what we get is that this function will display the column names present in our data set, As you can see over here, it has displayed as the query and response columns that we named earlier. And when we have a data set with a lot of column names, we can use this df.columns, which will displace all the column names. We can also use another function, which is df.keys, which will do the same thing. It will also displace all the column names. So df.columns and df.keys both can be used in order to find our column names. And then the next function that we have used over here is df.info. So df.info will help us find out two things about our data frame. One is the presence of null values in our data frame, and the other thing that df.info will show us is the type of data present in that data frames column. As you can see over here, it has displayed the column names as well. Over here we have query, and then we have our response column. And over here, the next thing you can notice is here we have 3725, and at the same time you can see over here we have 375 rows. So when these two values match, it means that there are no null values present in that particular data set. And let's say we have a value called named 3000 over here. If we have a mismatch between these total entries and this value, then it means that around 725 missing values are present in that particular data frame. All right, so it will display us two things. It actually displays us three things. One is the column name, the other is the presence of null values. As you can see over here, there is a match between the total number of entries and these values, and that means that there are no null values present in our data frame. And as we saw earlier, we do not have any integer values. We have object type data present in our data frame, where both the column names, query and response, are of object types. And in order to get a clear picture, we can also use another function which is called as df.isnull.sum. So using that function, we can count the total number of missing values present in our data set. But as for now, we have used df.info, and this is the basic info of our data as we see here. And then the next function that we have used is the df.describe. So the describe function will show us the frequency, unique values, and counts of all columns. As you can see over here, the count for query and response column is 3725, and the unique values present in the query column are 3510, and when it comes to response, the unique values are 3512. And over here we have these top. What do you mean, so this is something that repeats for around maximum number of times in our data set, and this is the frequency. All right, and then we have used another function which is df.nunique. So what df.nunique does is that it is a function which returns the total number of unique elements present in our data. So as you can see over here, there are 3510 unique values in our query column and 3512 unique values in our response column. And then as I told earlier, we can also use this function df.isnull.sum. Again, this function will tell us if there are any null values present in our data set. And as you can see over here, we have 0 in query and 0 for response. That means that there are no null values present in our data frame. Let's say over here we have 10, then it would mean that there are 10 missing values present in our data frame. All right, so it will basically help us to find if there are any null values present in our data set or not. And then the next function that we have used over here is value underscore counts. So let's say we have two columns over here, query, and then we have response. So when we use value underscore counts, the value underscore counts will check the counts of the values present in our column name. So let's say we have a column called color, and in that column we have three colors, red, green, and blue. So value underscore counts will tell us that how many number of times a particular color, red or blue or green, is repeating. All right, over here we use the query column, and in that particular column, what do you mean repeats for 22 times? Why not has a count of 16? What happened has a count of 10, and so on. All right, so it will display the total number of times a particular value is repeating in a data frames column. Then what we have done is that we have used the same value underscore counts on the response column. And again over here you can see that what do you mean repeats for 22 times. And again the values are similar as compared to the query column. The only difference over here is this me too. All right, over here we have of course. All right, so value underscore count will display as the total counts of a particular value in a column of a data frame. And then the next thing that we have done over here is we have visualized our data. So over here you can see that we have done a data understanding. So data understanding will help us give insight about our data. But in order to get a clear picture, in order to get an in-depth perception, we can visualize our data set. So in order to visualize our data set, the other thing that we have done over here is we have used sentiment analysis over here. And what sentiment analysis will do is that it will help us to find out how many times a particular sentence is repeating and whether that particular sentence is positive, negative, or neutral in nature. So in order to do that, we have imported sentiment intensity analyzer. So this will help us to find out if a particular given sentence is positive in nature or negative in nature or neutral in nature. So this is that import. And what this import will do is that it will take in a string and it will basically return us a dictionary, and this dictionary will have values such as positive, negative, or neutral. All right, and then what we have done is that we have stored the query column in text. All right, as we are going to perform our sentiment analysis only for the query column. So sentiment analysis will give us a polarity score, and using that polarity score we can find out if a given text is positive, negative, or neutral. So sentiment analysis will aim to measure the attitude, sentiments of a speaker or writer based on computational treatment of a subjectivity present in the text. And over here we have used the query column and stored that in text. And then over here we have used the sentiment intensity analyzer. And then we have printed the sentence, and we have used the polarity scores over here on that particular sentence. And then as you can see over here, all the queries have been displayed like we saw earlier. Hi, how are you doing? And their polarity scores have been displayed as well. Over here, how are you doing has negative score which is 0.0, neutral score that is 1. So what this basically tells us is that this line or this query, hi, how are you doing, is neutral in nature. And then over here again positive is 0 and compound score is 0. So this has been displayed to every query present in that particular column. Over here, let's see, in this particular line, I'm pretty good, thanks for asking, is not negative in nature, and that's the reason why we have a 0. And then over here we have 0.25 when it comes to neutral. And over here we can see that the positive value is higher compared to other three sentiments, and our positive value over here is 75. That means this particular line is positive in nature, and this is the compound score. So we have given our text, and at the same time we have displayed the positive, negative, neutral, and compound scores below that particular text using sentiment analysis. And the next thing that we have done over here is we have used the sentiment intensity analyzer on rating, and then we have applied our polarity scores, And then we have concatenated all these positive, negative, neutral, and compound scores to our data frame. And as you can see over here, this is our data frame, which previously had only two columns. One is the query and the other is response. But now after concatenating our polarity scores, we have our negative column, neutral column, positive column, and compound score column. And now in order to visualize this text, we can use a word cloud. And over here, we have imported our word cloud. So word cloud will help us display all the words that are repeating in our data frame. So when it comes to word cloud over here, this is how our word cloud looks like. All right. And next thing is we have defined our word cloud and we have given the data frame and label. And then we have given a background color, which is black. As you can see over here, you can change the color by changing the color name. And then the maximum words that we are going to use in this word clouds is 1000. And then we have plotted the figure as we have imported matplotlib.pyplot as plt. So this is our matplot import. And then we have given a figure size, which is 20, 20. And then we have used the frequently repeating words, and we have given a font size of that particular word as 20. And then we have used this color map called as guest earth. And then over here you can see that we have given a random state that is 244. So what this does is that, let's say among five people, two people use the same random state, then they will have matching results compared to the other three. All right. And then we have displayed our word cloud, where we have given the query column from the data frame. And over here, these are the frequently repeating words in the particular column query. And the bigger the word over here means the higher the repetition of that particular word in the entire data frames column. Over here, you can see that words like yes, go, think, goodwill are huge compared to other words. That means these words have repeated for a lot of times compared to other words. And then we have displayed our word cloud for the response column. And again, as you can see over here, the bigger the size of the word, the higher the frequency of that particular words in that column name. Again, we have yes, going, go, think, want. So these words have frequently repeated in that particular column, which is a response. And once we have done the visualization, we can go ahead and normalize our text. So when it comes to text normalization is a process where we change our text and we convert the text into a usable form, where we remove all the special characters and we convert the text into lowercase, and such other things are done in text normalization. We also remove any non-ASCII characters or alphanumeric values as well. And the other thing that text normalization does is that text normalization is basically help us to convert all letters to lower or uppercase. So we are going to convert all the text into lowercase, and then we text normalization will also help us convert numbers into words, or it will help us to remove all the numbers. And we can also remove white spaces, expand abbreviations, and we can remove stop words, which are nothing but most frequently repeating words. So in order to do that, the first thing that we do is we import RE. RE over here is nothing but regular expressions. So regular expressions has been imported. And the next thing that you can see over here, we have converted the entire text column or the data frame into lowercase, and we have used the lambda function and used the re dot sub over here, and then we have used this lowercase over here. This will basically help us convert the text into lowercase. And then we have removed slash n's, and wherever we have slash n, it will be replaced by empty values. And then the next thing that we have done over here is we have removed all the non-ASCII characters. So basically there are no non-ASCII characters over here in the particular data frame, but this is a standard procedure. So wherever if there are any non-ASCII characters or ASCII characters, we remove them. And then the next thing that we have done over here is we have removed the alphanumeric values. And alphanumeric values are nothing but words with digits attached to them. So such values are again with the help of lambda functions, we have stored all those values into alphanumeric. And then what we have done is that in the particular query column, we have mapped the alphanumeric and the and all these slash n's which were stored in remove n. So whatever special characters that we have stored in these particular names, we have used the map function and removed all those special characters and extra slash n's and alphanumeric values. And same thing has been done on the response column as well. We have removed all these special characters, non-ASCII characters, slash n's, and we have treated our query and response columns and cleaned them. And then the text has been normalized over here, and this is how our final data set looks like. So if there were any special characters in these particular column names, we have successfully removed them, and hence this is our final data set. And what we have done over here is that I've given a pd.set underscore option, display max rows. So what this does is that over here you can see that there are three dots over here. So basically our data frame shows us the top 5 rows and bottom 5 columns. And using this pd.set underscore option, we can display all the rows in our data frame. As you can see over here, after using this function over here, which is pd.set underscore option, and then you have to give a value over here. I've given 3800. So it displays us all the rows in our data set. And as you can see over here, we can see that there are no special characters or any such values in our text. All right. As you can see over here, the next thing that we have done is that we have arranged a particular column name in a descending order. So let's say we want to find out if a particular sentence or a query is positive, negative, or neutral. What we have done is that we have arranged our data frame in such a manner that the negative column, if arranged in descending order, will show us the highest negative sentence that's present in our data set. In order to get a better understanding, let us go ahead and see the code. Over here, in order to find out the most important sentence, we know that the compound score must be high. And then what we have done is that we have used the sort underscore values by compound. So using compound, we have sorted the values in a descending order. So what you can see over here is that when we use the important sentence dot head, you can see over here the data is arranged in such a way where compound score is highest, as we have arranged this column in descending order. And as you can see over here, this particular sentence or query has the highest compound score, which is 0.9, and that particular query is of index 1019. So over here we have, if we are good, we will be happy in heaven. So this particular column is the most, this particular query is the most important sentence, and we have used the compound score. And in a similar way, we can also find out if a particular sentence is positive, negative, or neutral. So the highest positive sentence over here, again, we have used the same code, but over here we have changed the compound to POS, which is our positive column. And again, we have arranged that in a descending order. And as you can see over here, we have used the df dot sort underscore values, and we have arranged the data by the positive column. And again, we have arranged this data in descending order. And then we have printed the first five lines of our data, or the first five rows of our data. And as you can see over here, now these data set has been arranged based on the positive columns highest scores, and words like please, yes, well, congratulations are positive in nature. So these top five, these are the top five positive words in our query column. And in a similar way, we have also used the sort underscore values on the negative column. And over here, we have stored the negative queries in neg underscore sent. And over here, we have arranged the columns with the name negative. And we have arranged this column in the descending order. And as you can see over here, we have printed the negative sentences over here. These are our first five rows. And as you can see over here, no, no problem, no, I hate vegetables, never, better, thanks. So these are negative in nature. And in a similar way, we have also used the same thing on our neutral column. What we have done over here is we have sorted the values based on the neutral column and arranged them in a descending order. So ascending equal to false means we have arranged our data in descending order for that particular neutral column. And then we have printed the neutral head. So neutral head over here will show us the top five first rows, top five first rows. And over here you can see that neutral column over here has high values. So how are you doing? We get hamburgers and stick. What is gravity? So these particular queries are neutral in nature. And then in order to start working with our chatbot, what we have done is we have imported another library which is called the TF-IDF. So TF-IDF vectorizer, what it does is that TF-IDF vectorizer will basically transform text to feature vectors, which can be used as an input to estimator. So it converts each token or a word to feature index in the matrix, where each unique token gets a feature index. All right, and using this TF-IDF vectorizer, what we have done is that we have stored the TF-IDF vectorizer in TF-IDF, and then what we have done is that we have used the TF-IDF.fit underscore transform on the query column. Then we have changed it to an array, and basically this code we have changed the column into array, which is our query column. And then we have displayed the feature names of the TF-IDF, and we have done that with the help of TF-IDF dot get underscore feature names. So these all are our feature names over here: afraid, afford, after, after. After that, what we have done is that this is the application part. All right, and when it comes to the application part, once we have converted our query column into TF-IDF, we have used another metric over here, which is the cosine distance. So what this does is that this import over here, sklearn.metrics.pairwise, from that we have imported our cosine distances. So what it does is that it is a cosine similarity. So what it basically does that is that it will measure the similarity. It is one of the most widely used and powerful similarity measure in data science, and it is used in the cases of NLP or natural language processing. It is also used in multiple applications, and what it does is that it will find similar documents in NLP, and it is used for information retrieval, and it can also be used to find similar sequence to a DNA in bioinformatics. So basically, we have used the cosine distances over here in order to find the most widely used and powerful similarity measure in our data. And then what we have done is, after we have imported the cosine distances, we have defined a chatbot where over here we gave a query, who are you? And then we have defined a chatbot. So what it does is that it will, first step would be to clean the text or query that's given to it. And then we transform that clean text into an array using the tf-idf dot transform. And then we have applied the cosine similarity over here, which will give us the similarity score on factors and query vector. And then we have taken the max index position. The next thing over here you can see that is that we have searched or we have used this matching question, and then we have used the df dot lock on that particular index for the query. And then similarly we are also going to display the response, and using the df dot lock it will give us the response over here. And then we have given the positive score, negative score and neutral score, and then display the confidence confidence using the similarity score over here. And then this is our dictionary where in match we have given the matching question, response is over here, response again. And then what we have done is that we have returned the chat dictionary. And then what we have done is uh, we have given the input user, so this will basically take the input that we give. And when we type exit, the application or program will end the chatbot when we type in exit. And then over here, this is our chatbot that we defined earlier. All right. And then over here, this is the score, where if our score is less than equal to 0 0.2, then the bot or program will display this. Please rephrase your question. All right. And then over here we have given the print command over here, where equal to sign will repeat for 80 times, as you can see over here. And then what we have done is that we have given the print command over here, which will display as the matched question. It will show us the confidence score, and whatever a query has been asked to our program, it will also display its positive score, negative score and neutral score. All right. And then again, this is our print command, which will display us 80 equal to a symbol. It will this equal to sign will repeat for 80 times. And then we have printed board, and this is going to be our response over here. And as you can see over here, these are all the texts or queries that we gave to this chatbot application. And over here we have given hi, and it has returned us an answer which is, hi, how are you doing? All right. So this is basically nothing but the matched question. So it has matched this input hi to, hi, how are you doing? And then it has displayed as the confidence score, and it has given us the positive score, negative score and neutral score. And as you can see over here, the neutral score is higher compared to the other scores. That means this particular input that we gave to our chatbot program is neutral in nature. And then the bot has responded, I'm fine, how about yourself? And then we have given this input again. So wherever we see user, it is nothing but the input that we gave to our model or chatbot. And over here we have given, I am good and did you get fat? So over here you can see that it has given us positive score, negative score and neutral score. So basically our input, it has classified it as neutral in nature. And then the bot has responded, no, but I did put on a few pounds. And then this is our next input, and we have given, it looks like it may rain today. And then it has matched this query over here. And then the confidence score is 73. Again, it is neutral in nature. And then the bot has responded with hopefully it will rain. And then these are our inputs that we gave to our chatbot. And as you can see over here, this particular input, I really love how rain clears the air, has highest positive score. So basically it says that this query is positive in nature, and after positive it is neutral in nature. So over here we can see that our chatbot has performed very well. Using the cosine similarity, we find out which query is similar to which uh, query present in that particular data's column. And then we have displayed the sentiment scores, whether if the given input is positive, negative, or neutral. And then over here in this line, you can see that we gave, did I tell you the good news? So it has given that particular input as neutral and positive again. And in the end, what we have done is that we have given exit. And as we saw earlier in the code, that whenever we type exit, the program quits and the chatbot ends. So this is how we have created our chatbot, and this chatbot works very well. At the same time, this chatbot gives us the sentiment of the input given by the user. And so far, this chatbot works very well. And that's it for this video. Hope you like this video, and until then, have a good day. I will see you soon in the next video.